Hello everyone. Today let us revisit the chapter of statistics.
Statistics is mainly about three things, that is collection, analysis and interpretation of the data. Now let us look some basic terminologies in statistics, starting with frequency. Frequency is how often something occurs. Here is an example of Sam playing football twice on Saturday, once on Thursday and overall 3 times a week. Here the numbers 2, 1 and 3 represent the frequencies of his play during the week. Next is a frequency distribution table. This is a data table which consists of the given data with its corresponding frequency. There are two ways of putting it. One is ungrouped frequency, where each value is represented individually, and in the second phase we call it as grouped frequency distribution table, where the given data are grouped in terms of intervals. These intervals are called as class intervals. As you can observe here, the numbers are grouped in the intervals of 0 to 5, 5 to 10, 10 to 15 and so on. The values that are on the left are called as lower class limits, and the values that are on the right are called as upper class limits. And the difference between these two is called as the class size or the width. That is, width is equal to upper limit minus lower limit. Here is an example of the class width of the first class interval, which is 5 in this case. Next, let's move on to our class mark. Class mark is the representative of our class interval. That is, whenever I take an example of such, so class mark is given by the formula upper limit plus lower limit by 2. Considering my first interval, which is 0 plus 5 by 2, which is 2.5. 2.5 is my class mark, that is my class representative of the first interval. The measures of central tendency is a single value which is a representative of all the data that has been collected. There are three measures of central tendency. One such is the mean, which is basically commonly known as the average, that is sum of all the terms divided by the total number of terms. The second one is the mode, which is the most repeated term. The third one is the median, which is the middlemost term of the given set of data. Let us begin with finding the mean of the group data by direct method. Let us take an example to understand this better. Here is an example in which the class interval and the corresponding frequencies are given. So first let us find the sum of all the frequencies. Then find the class mark of all the class intervals, that is upper limit plus lower limit by 2, which is in the first case it is 0 plus 20 by 2, which would give me 10. Same is the procedure for all the class intervals. Next, my step is to find the product of f and x, that is 15 into 10, 18 into 30 and so on, and sum them up to get summation of fi xi. The mean by the direct method is given by the formula summation of fi xi by summation of fi. On substituting the values, I get the mean as 53. My next method is the mean by assumed mean method. As the name suggests, we are going to assume a particular value and find the mean. Here is the same example. We are going to follow the same procedure in the beginning. That is, we are going to find the value of class mark initially. Then, among the values of xi, the class mark, we are going to assume a value, suitable value, that is, to our convenience, we are going to assume it at the center. Here it is 50. We are going to assume the value of a to be 50, which we call it as the assumed mean, and find out a deviation, that is, how far the assumed mean has deviated from the given set of values of xi, that is 10 minus 40, 10 minus 50, which is minus 40, 30 minus 50, it is minus 20 and so on. My next step is to find the product of f and d, that is the frequencies and the deviation, 15 into minus 40, 18 into minus 20 and so on, and total them up. The formula to find the mean by assumed mean method is given by mean is equal to a plus summation of fi di by summation of fi. On substituting the values, I get the mean as 53 again. My last method is called the step deviation method, which is the continuation of the assumed mean method. We are going to follow the same procedure that we did in our previous method, that is until we find a deviation. Here the value of a is 50. Now we observe that in the column of deviation, all the values are the multiple of my class size, which is 20. So I'm going to divide by each of my values by 20. That is, I'm going to call it as ui, which is equal to di by h. That is minus 40 by 20, which would give me minus 2, minus 20 by 20 would give me 1, minus 1, 0, 1 and 2 and so on. My next step is to find the product of fi and ui. So I'm going to multiply these two columns to get my required answer. Then I'm going to total them up. So I'm going to get summation of fi ui to get 15. The formula for the step deviation method is a plus summation of fi ui by summation of fi into h. On substituting the values, I get mean as 53 again. So here I observe that the value of mean is 53 in all the three cases. So I can say that which irrespective of the method that we use to find the mean, the answer would still remain the same. Moving on to our mode, that is our most repeated term. Let us see how to find the mode of a group data. Here is an example of the same. Here when we look at in the column of frequency, we see that 29 is the highest frequency. The class interval which has highest frequency is called as model class. Here in this case it is 60 to 80 which has the value 29. The lower limit of this is called as the value L which is 60. Since 29 is the highest frequency, I would represent it as F1. The value before to it is represented as F0. The value after the highest frequency is represented as F2. The mode of the group data is found by this formula. On substituting the given values that we have obtained now, I'm going to get mode as 68. Now let us look at how to find the median of the group data. Here is an example in which the class intervals and the corresponding frequencies are given. Here the sum of the frequencies is represented by the letter capital N. Here we find an additional quantity called as cumulative frequencies. As the name suggests, the values are cumulative. That is, we add the frequencies up to a required level. The first value is 15 and the second value is 15 plus 18, 33, 33 plus 21 will give me 54 and so on. As we observe here, the highest value of the cumulative frequencies is equal to sum of all the frequencies. Now, median class is a class which has a cumulative frequency greater than or nearer to the value of n by 2. Here, the value of n by 2 is 50. As I look into the column of cumulative frequency, the value that is nearer or greater than value of n by 2 is 54. So I mark 40 to 60 as my median class. The lower limit of this median class is 40, so I take the value of L as 40. The median of the group data is given by the formula L plus n by 2 minus Cf by f into h, where f is the frequency of the median class and Cf is the value of the class that is preceding my median class. On substituting my values, I get median as 56.19. Now let us look at the empirical relation between the mean, mode and median, the three measures of central tendency. Empirical relations are the relations that are based on the observations. So the formula or the relation that connects all the three is 3 median is equal to 2 mean plus mode. Moving on to our next concept called as cumulative frequency graphs, or just call it as ogive. So these ogives are basically plots of cumulative frequency on y-axis and the limits on the x-axis. There are two types of ogives, namely less than type ogive and more than type ogive. In the less than type ogive, the upper limits are considered on x-axis, and in the more than type ogive, lower limits are considered on the x-axis. A less than type ogive. Whenever we are given a normal problem, it is essential to convert the given frequency table into a cumulative frequency table. Here we observe the value of less than 120. There is only one value that is less than 120, which is 12. The next is less than 140. There are two values, that is 12 and 14. Together would give me 26. Like this, I add 18 to get 8. Then I add 6 to get 40. Then I add 10 to get 50. Once I am done with my converting the table, I would consider all the upper limits on my x-axis and all the cumulative frequency on my y-axis to plot a ogive. Now let's see how to plot a more than type ogive. So here also the same example. Here also we're going to convert the given table into a cumulative frequency. As the name suggests, more than or equal to 100. Here all the values are more than 100. More than or equal to 100, which would give me 50. So more than or equal to 120. That is, except the first value, all the values are more than or equal to 120. So I subtract 12 to get 38. Next, I subtract 14 to get 24 and so on. Once I'm done with forming a table, I would take my lower limits on my x-axis and cumulative frequency on my y-axis to obtain the smooth ogive curve. Once we are done with the plotting, we also know that we can obtain the median from the graph. Here is an example of a ogive, that is a less than type ogive. Now, whenever we know the value of frequency, that is sum of frequency, here in this case I am considering it to be 35, I would find the value of n by 2, which is 17.5. I would want to locate the value of 17.5 on the scale of cumulative frequency, that is on y-axis. From there, I would draw a horizontal line until it meets the graph, and then the vertical line until it meets my x-axis. So the value that I obtained there is the median of the given graph. I hope this video was quite helpful. Thank you for watching.